Hello my dear students, in this video now we are going to study about the Barton reaction and its mechanism, and we will look at some examples related to the Barton reaction. Barton reaction is a photochemical reaction. In this reaction, alkyl nitrites will convert into the nitrous alcohol. This is the basic reaction, basic equation of this reaction. Alkyl nitrates are the compounds in which ONO linkages are present. So look here, ONO linkages are present. Okay, na? So such type of compounds are known as the alkyl nitrates, and we have to know that NO group, N double bond O group is here known as the nitroso group. Okay, na? So in the product of this reaction, we will have one nitroso group and one hydroxy group. So that's why the product will be called as the nitroso alcohol. So in the Barton reaction, alkyl nitrite will convert into the nitroso alcohol. Then now we go for the mechanism of this reaction. So in the first step of this reaction, first of all, ON single bond of the nitrate bond will undergo homolytic cleavage. So this ONO bond undergo homolytic cleavage. As a result, we get nitroso free radical as well as the alkoxy free radical. Alkoxy free radical. In the second step, this alkoxy free radical undergoes a 6-membered transition state. Okay, and it abstracts hydrogen from the fifth carbon. So that's why Barton reaction is known as the 1,5 hydrogen shift reaction. So in a Barton reaction, hydrogen will be shifted from fifth place to the first place. Here the oxygen is considered as position of the oxygen is considered as the number one position. Okay, so here hydrogen is shifted from fifth place to the first place. So that's why Barton reaction is known as the 1,5 hydrogen shift. If we use the Greek letters, we give the numbering, naming like this: alpha, beta, gamma, and delta. So that's why Barton reaction is also known as the delta H abstraction. So in any way we can call. Okay, so we can call it as the delta H abstraction, otherwise 1,5 hydrogen shift. So these two names we can use for the step 2. Okay, now 1, hydrogen shift or delta H shift. Next, in the second step, we get the hydroxybutyl free radical. Okay, na? So this is the hydroxybutyl free radical. Hydroxybutyl free radical. In the third step, the nitroso free radical formed in the first step attacks on the alkyl free radical at the fifth place. As a result, we get the nitroso alcohol product. So these are the main 3 steps. But here at the fifth place, we have the 2 more hydrogens. If in the place of the hydrogen, if we have the alkyl groups, the reaction will stop here only, and nitroso alcohol will be the end product. But here in this case we are having 2 more hydrogens. So that's why the reaction will not stop here and it proceeds further. As a result, what happens, we will look at. So in the step 4, what happens, the CH bond breaks and N double bond changes into the single bond, and this hydrogen will come onto the oxygen. As a result, we get the oxime in the fourth step. And one more hydrogen is there at the fifth carbon. As a result, it may go into the step 5. In the step 5, dehydration takes place. Look here, this CH bond breaks here, and this OH group goes outside. As a result, water goes outside. As a result, we get the nitrile group. So fifth carbon changes into the carbon of the nitrile group. And the name of this product here, it is 4-hydroxybutane nitrile. Okay, so at the delta position or at the fifth carbon, only one hydrogen is there. Then the end product will be the nitroso alcohol. And depending on the number of the hydrogen atoms present at the fifth place, either we will get oxime or we will get the nitrile. Now we will look at some examples. Look here, in this question, this hydroxy compound is taken. Look here, starting substance is hydroxy compound, and it is treated with the nitrosyl chloride in the presence of pyridine and light. So here we have to remember that hydroxy compounds are acids, and in the presence of pyridine, these alcohols or hydroxy compounds react with the NOCl, and as a result, we get the nitrite compounds here. So this is the first step. In the presence of pyridine, hydroxy compounds react with pyridine, means it is a base. Pyridine is a base. Alcohols are acids, and in the presence of base, they react with the nitrosyl compounds NOCl and change into the nitrites. This is a nitrite. This is nitrite. Okay, now, and then after it undergoes Barton reaction. Look here. So this is the otherwise alpha, this is beta, this is gamma, and this is a delta carbon. We can use alpha, beta, gamma, delta, or we can give the numbers also. From oxygen we have to count 1, 2, 3, 4, and fifth carbon. So this is the fifth carbon. Okay, na? So in the Barton reaction, nitroso group come on to the fifth carbon, and the oxygen of the nitrite will change into the hydroxy group. So okay, na? And then after this nitrite undergoes tautomerism, and we get the oxime. So conversion of the nitroso group, in the first example I forgot to say. Look here, the conversion of the nitroso group, sorry, what is it? I write once again. So look here, this is nitroso group. So this nitroso group changes into the oxime. So look here, hydrogen is shifted from this carbon to this hydrogen. So shifting of such groups is known as the tautomerism. So nitroso group undergoes tautomerism and forms oxime. So this is example for the tautomerism. So okay, so this is the product in this reaction. Okay, now we go for the second question. Look here, in the second question also, direct nitrite is not given, hydroxy compound is given, and we have to understand that in the presence of pyridine, nitrosyl chloride reacts with hydroxy compounds and forms the nitrite. Okay, so in the first step, nitrite is formed like this, and now we have to check which look here, we have to identify the positions: alpha, beta, this is beta, and this is gamma, and this is delta, and this carbon is also delta. So two methyl groups are the delta methyl groups. So now we will get a doubt on which methyl group nitroso group has to be substituted. Okay na? So but here we have to remember that here Barton reaction takes place through a six-membered transition state. No, so for that to occur, nitroso group and the delta carbon should lie in the same plane. So look here, in this example this nitrite group and this carbon are lying in the same plane. So that's why nitroso group will attack on this carbon, not on this carbon. As a result, we get oxime at this carbon only, oxime at this carbon only. Okay, so look here, methyl group, delta methyl and nitroso group are lying in the same plane, so we get the product here. Next, question number 3. So it is a very simple question. Look here. So to identify the product, we have to look at the delta carbon. Okay. So this is a very simple thing. Look here. So this is alpha, this is beta position, and this is gamma, and this is delta. Okay, na? So this bond will break, and nitroso group will be substituted at the delta position like this, and this one in turn changes into the oxime. Okay, so this is nitroso compound and this is the oxime. Okay, na? Due to the tautomerism, nitroso group changes into the oxime. Okay, next question number 4. Look here, this nitrite and this bond of the cyclopentane are lying in the same plane, so we may easily expect what will be the product here. So here this is the product in this case. Okay, next question number 5. This is also very simple. So we have to identify the positions. First of all, alpha, beta, what is that, alpha, beta. Sorry, I have written a wrong question here. Actually, I have tried one more bond here. Okay, na? Alpha, beta, gamma. So this is the wrong one. Okay, sorry. Next, we go for the next two question. Look here. Here in this compound also, we have the two methyl groups at the delta position, alpha. Look here, this is the alpha, this is a beta, this is a gamma, and this is delta. Beta, this is gamma, and this is a delta. Okay, so two delta methyl groups are there, and these two groups are lying in the same plane to that of the nitroso group. So these three groups are in the same plane. Here now we have to think on which delta methyl carbon nitroso group will be substituted. So look here, the nitroso group will be substituted here, this carbon, and we get the oxime here. This nitroso group will not be substituted on this carbon. Why? Because look here, this methyl group is present adjacent to the electron withdrawing group. So the delta methyl group which is adjacent to the electron withdrawing group undergo Barton reaction. As a result, we get this product. Okay, now we go for the question number 7. So here what happens, we have to look here. Okay, so first of all we have to identify the positions. Okay, now this is alpha position, beta position, gamma position, and delta position. So in the delta position, instead of the simple sigma bonds, one double bond is there. In that case, what happens means, look here, the alkyl oxygen free radical formed here undergo cyclization and we get a cyclopentane ring. Here there is a possibility for this oxygen free radical to attack on this carbon also, but formation of the five membered ring is more favorable than the formation of the six membered ring. This rule is known as the Baldwin rule. So according to the Baldwin rule, formation of the five membered ring is more favorable. Okay, as a result, we get this five membered ring and a free radical here, and then after the nitroso group attack on this free radical, as a result we get this one, and at last we get the oxime here. Okay, yes, at last we get the oxime here. Okay, now we go for the question number 8. So look here, this is a hypochlorite. So instead of the ONO bond, here under instead of the nitride bond, we are having the OCl bond. OCl means nothing but OX bond. Okay, na? So a bond is there between oxygen and halogen. So this bond is also less stable. Okay, na? Because like oxygen and nitrogen, oxygen and halogens are also strong electronegative atoms. As a result, the OX bond becomes unstable. Okay, so these hypohalites, these are such compounds are known as the hypohalites. Okay, the compounds which have OX bond are known as the hypohalites. So hypohalites are unstable. They also show the Barton reaction. So look here. So first of all, we get the 1,5 diradical. Then this with the removal of HCl. So here the HCl will be removed and we get this radical. And this diradical undergoes cyclization and we get a 5-membered furan. Tetrahydrofuran. This is known as the tetrahydrofuran. Okay. Now we look at this question. Look here. So first of all, we have to locate the positions: alpha position, beta position, and this is the gamma position, and this is the delta position. Okay, na? So actually here hydroxy group is given and NIS is given. NIS means N-iodosuccinamide. This is N-iodosuccinamide. This is N-iodosuccinamide and it is a iodinating agent. Okay, na? This will give iodine group. This will form OI bond. Okay, na? So which in this OI bond in turn undergoes the Barton reaction. No? So that's why look here, first of all we have to write iodine at the hydroxy group. Okay, na? Hydroxy group should be changed into the hypoiodite bond. Okay, na? So and then after what happens in the presence of light, this changes into the free radical. Actually this Bn means benzyl group. So here we have to expand this one. So on expanding, this one become, this carbon of the benzyl becomes the delta carbon. So look at alpha, beta, gamma and delta. So here in the presence of the light, Hi goes outside. As a result, we get this 1,5 diradical. Okay, na? 1,5 diradical. And this 1,5 diradical then undergoes cyclization and we get this 5-membered ring. Okay, now this is a special reaction. We have to concentrate on this one. Okay. Thank you for watching.